So in this activity, sorry you were missing it, but hopefully this will help you understand what we did. So in the CER density cubes, the focus question is what are the densities of different metals? And so we have a bunch of these little metal cubes called density cubes. They're all made of different metals. So once again, when you normally you'll write your own background. Once again, the background, you can find the checklist for what is important for a CER background section on your first page of your notebook. So backgrounds need to have some information that's helping your reader. So I look at the title, density cubes, and I look at the focus question, what are the densities of different materials? And I ask myself, what of those words in there that might my reader not know and need a little bit more background on? So I'm like, maybe they don't know anything about densities. Maybe they don't know much about metals. So I'm going to give them at least 3 sentences explaining some background information. So when they read the rest of my piece, they have some context for it. In this case, I'm actually giving you the background. Another part of the background, once again, if you're looking at the checklist on page 1, is you need to have a cited source. So we watched a video in class. So my background, according to the PBS video, Eureka density, so I'm citing the source, density is the degree of compactness of a substance. It is calculated by density equals mass over volume. So I'm giving them the formula. And the units of density are grams per milliliter or grams per centimeter cubed. So I have at least 3 sentences there. And then what I'm going to do is you're going to circle the claim that you think is correct at this point before doing the experiment. So the claim is these cubes, okay, made of different metals have either they're all the same volume, do they have the same density or different density? So you're going to circle the one that you think is correct. Now, in order to calculate density, you need a formula. So once again, the formula for density is mass over volume. So once again, I heart density because there's a little m divided by v. Okay, so what we're going to do is we're going to take our first little cube. So this is lead. And in order to get the density, I need to know the mass. So I need a scale and I need to calculate the volume. So basically, I'm going to take my little scale. I'm going to make sure it's a little hard to say. Oops, it isn't. Well, you're not going to quite be able to see what I'm doing. Okay, so I'm putting it on the scale, and I'm getting the mass of it. So I got to set it to 0. And I get, I already put it on there, 89.56. So then I'm going to I have to calculate the volume. And so this is a cube. So you might remember, just kind of pause for a second to remember from math class, how do you calculate the volume of a cube? So you might remember length times width times height. And for obviously a cube, you can also just go side times side times side. And if I measure really carefully with my ruler, it's 1.9 centimeters. If you did 2, it's fine. Obviously, you're not doing it because you're watching this video instead. But so then I'm going to calculate the volume. And once again, think about your estimating skills. This is about 2 times 2. So 2 times 2 is 4. Times 2 again is 8. So this can be somewhere close to 8, but less than that. So when I put it on the calculator, I get 6.859. It's a little bit of a complicated concept, but our scale is not that precise, nor is this thing that precise. So we're not going to get something with that many decimal points. So we're going to just round it. And we're going to be more like this is 6.9. So I'm going to round 8.5 up to 6.9. The units, centimeters times centimeters is centimeters squared. Centimeters squared times centimeters, again, gives me centimeters cubed. So this number here is going to go up into the volume section. And since all of the cubes are the same size, we're going to use that same number for all of them. Okay, so I'm going to give you the masses for the rest of them in just a second. Okay, so here is the rest of the information after I put all my things on the scale and I got the mass of the different things. Once again, these symbols are the symbols from the periodic table of elements. Um, some of them, like aluminum, makes sense, Al, but some of them look a little weird, like why would lead be Pb? And that's because these are some of the older names from ancient Rome. So now we need to calculate density. And if you remember above, there's a formula for density. Density equals mass over volume. That's why I heart density. And then I'm going to, in my calculation section, so if you've got a data section and you need to do stuff with it, you need to also have a calculation section. So I'm going to put down my formula for density. And then what I'm going to want to do is I'm going to make it clear to my reader that I'm calculating the density of lead. I'm calculating the density of iron. So I'm going to kind of do the same thing that I did above. So I'm going to be like density, and then I'm going to do a little subscript. These are called subscripts. So I'm going to do the density of lead. So I'm first going to find the mass. So once again, I'm using the formula density equals mass over volume. So I have to find the mass of lead, which is 89.56. And I'm going to put the units here just so you can see where we get the units for density over here. So the units are grams, and I'm going to put this over the volume. Excuse me, sorry. The volume was 6.9 centimeters cubed. Excuse me. So then I'm going to calculate that out. So I'm going to put into my calculator 89.65, and then that bar tells me to divide by 6.9. And I get 12.99. So I'm going to basically say this is like, let's just say 12.99. Okay. And then how do I know what my units are? Well, it's in the numerator in the top part, it's grams over centimeters cubed. So I actually get these weird units right up there, grams per centimeter cubed. So this was the density for lead. So I'm going to take the density for lead and I'm going to stick it up there. I'm going to put my units. Okay. So you're going to do the same thing for the other substances. So we're going to be like density, and we'll just kind of keep going on. Density of, and the next one was iron. And then you're going to give me what is the mass divided by the volume. And then you're going to plug it in there. So I want to see you put the information down on your paper. And then I also want to see you put it on the thing. Then when you get to the evidence section, I once again look at page one. Page one tells you the things that you need to have in an evidence section. So you're going to be stating the data, and you're stating data to prove your point. So here's your claim. These cubes made of different metals have the same or different densities. So you're going to have your claim. If you need to revise it, do that. And you're like, do you think you need to use all 4 pieces of data in order to prove that they're the same or different? Or is just 2 pieces of data going to be enough to prove that they might be the same or different? So you're going to say, state the data. You're going to compare the data. You're like, these numbers are different. These numbers are the same. Give me a number. How are they different? They're different by this many grams per centimeter cubed. And then you're going to make sense of it. Because they have the same or different density, that means this. Actually, same or different volumes. You can talk about the volumes, or it gets a little tricky here. Yeah, so you want to be talking about the data. And then when you get to the reason section, why do you think they have the same or different densities. So you might start with the good sentence starter would be, the reason they have the same or different densities is because blank. Okie doke. Good luck with that. Once again, not being graded, but we just want you to get in the habit of like thinking your way through these. And we look forward to seeing you in class soon.